Hi there, I'm Professor E. Welcome to the Robot Program. In this episode, I'm going to talk a little bit about the history of robotics, and I'll also give you some more information about some robotic applications. The idea of artificial or mechanical people has been around since ancient Greece and ancient Egyptian mythology. One ancient Greek mathematician had plans for a steam-propelled bird, a mechanical bird that could fly on its own that used steam as its method of propulsion. This is an example of early robotics. We have a creature that is mimicking something in real life that can move on its own without having any organic components. Another example in 1495 was Leonardo da Vinci's plans for a mechanical humanoid robot. He had a design for a knight in full armor that could sit up, wave, move its head, and move its jaw. It's not known whether or not he actually tried to build this robot, but his designs were found later on. The field of robotics has also been developed through science fiction. In the 1940s, Isaac Asimov came up with his 3 laws of robotics. This was the idea that robots had to be controlled by 3 different laws. The first law is that a robot may not harm a human being or through inaction cause harm to come to a human being. This was later revised to humanity rather than just a human being. The second law is that a robot must obey orders given to it by a human being unless those orders would conflict with the first law. The third law is that a robot must protect its own existence unless that conflicts with the first 2 laws, in which a robot has to take commands from a human or not cause harm to come to a human being or humanity. The 3 laws of robotics was one of the first times that the actual word robotics was used. Also in the 1940s, the concept of cybernetics was introduced. Cybernetics is the process of defining anything that controls technology, and it forms the basis for modern robotics. As we continue to develop robotics technology, cybernetics allows us a way to examine the communication and the systems control within a machine. Modern autonomous robotics really took off in the latter half of the 20th century. The first electronic autonomous robot was developed by William Gray Walter, and it was meant to simulate what happens with just a few brain cells and all of the different complex connections the human brain is capable of. So in this case, we're trying to get robotics to simulate what the human brain is capable of. And we see that theme come up again in a lot of different robotics developments. We see all sorts of different modern applications that use robotics. That can be anything from safety. How can we send in a robot for disaster relief? Maybe it's bomb diffusing. Somewhere where a human would be unsafe, we could send in an artificial human to do the same task. And in order to achieve that kind of a task, we need to look at things like sensors. So ultrasonic sensors, they help give us distance information. We've got things like cameras, also providing us visual feedback. Tactile sensors, audio sensors. Another field is the area of prosthetics. How can we use robotics to mimic or replace parts of the organic human body? We want them to behave in the same way through arm joints or touch, feel, grasp. How can we replicate all of those things using robotics? We can also take inspiration from the natural form. Biomimetic robots are robots that take inspiration from animals, nature, plants. They might move in the same way that the animal does, or maybe they're patterned in the same way that an animal is. So for instance, we take a look at the gecko. The gecko is able to walk on the wall using little teeny tiny fibers on the bottom of its feet. We can then take that inspiration to develop things like Velcro, or we can go on to develop a surface that would allow a robot to stick to a wall and climb up it. Robots can even be found in homes now. Look at something like the Roomba vacuum. It's an autonomous vehicle that can go around and clean your carpet or clean your floor for you. It's an example of how a robot is being used in modern day life. Modern robotics can also be used in fine arts or service. So using the sensory feedback in our control systems, we can have robotic musicians. We can have robotic artists as they use artificial intelligence to learn about different patterns in art. And we even see robots in the service industry. So something like the InMove robot that we've demonstrated in previous episodes is able to pour a glass of wine for a human who maybe can't get up and get to the kitchen themselves. Another technology that uses concepts from the field of robotics is autonomous vehicles. If a car is going to drive through a city on its own, it'll need feedback from sensors, it'll need to be monitoring conditions, and it'll also need to be capable of making decisions for itself. Robotics can be used to extend human capabilities, including grabbing things, holding things, even things beyond human strength. And a great example of this is the Canadarm. The Canadarm, also called the Space Station Remote Manipulator System, allows crew members of the International Space Station to achieve tasks on a large scale that normal humans wouldn't be able to do, especially in a harsh environment such as space. The Canadarm was capable of grasping huge payloads, manipulating different items, and even docking the space shuttle when it came to the International Space Station. The original Canadarm was retired in 2011, and the second generation is even more advanced, with more sensors, more control, and more feedback to help facilitate the enormous tasks that it has to undertake. Robotics has an interesting history, and the field continues to grow. We can use robotics to help society, improve conditions. We can use it to expand our exploration of space, and we can even use it to explore our everyday creativity. At Easy Robot, we have a passion for robotics and technology. Thanks for watching this episode, and we'll see you next time. Research your favorite application of robotics and tell us in the comments. Find the answers at therobotprogram.com.